Hey everyone, we are finally back with another Making Games and Construct video, and what we're going to talk about in this particular video is, you might remember, here's level 1. Twice in level 1 we have a situation where at some point the scrolling stops or locks, and then there we go, there's one of them. There's basically a sub-boss fight. You have to beat a certain amount of enemies in order for the scrolling to restore itself, which you'll see in a second. There we go. And then you go back into the rest of the level. So we needed the same sort of thing for level 2. So what we decided was that these ram men creatures, when they're at war with other people, what they do to demoralize and attack the enemy is to, anyone they have captured, any of the soldiers from the other side they have captured, they'll entomb it in blocks of ice and basically lob, through some means which we'll reveal later, they lob those blocks of ice at the enemy. So you'll see in a moment the screen is going to lock, and then there's a shadow, and there you can see the friend of mine that's been entombed in a giant cube of ice. So that's what we're going to cover today, is the code that makes that work. Okay, so here are the actual events that make this all work. I put them in a group, and I just quickly cloned the group from level 1. That way I would just change things. Construct automatically adds a number to the end, because no two groups throughout your entire project can have the same name. Just to save time, I started with the stuff that creates the birds, and then I just edited and replaced the code as needed to make it do what we need. You can see here, for each scroll stopper, I'll explain what that is in a minute. Basically, if its X position is a certain point within the viewport left, or a certain distance from viewport left, then we're going to change the variable of that particular scroll stopper, which is, the variable is called triggered. If it is 0, you can see we end up setting it to 1. So basically I just created my own custom variable in it called triggered, and then that's going to basically wake it up. That's going to say, okay, yes, I am triggered. And then in this case, we're also doing an ice boulder count equals 0. That actually might not even be relevant anymore. That might have been one of the things that's kind of lingering from when I was fixing a bug before. All right, so let me quickly show you what that scroll stopper is. So foreground is visible. So there's the first one. So that just allows us to very easily tweak where these different little scroll locking sub-boss situations happen. You could see the second one here. So it just allows for very organic editing instead of hard typing in numbers like, if the X position of the camera reaches a certain thing. Viewport is the visible area of the screen. So if we say if it is within a certain range of the left-hand side of the viewport, that means has it scrolled onto the screen. So we're setting locked to 1, and we're setting triggered to 1. Triggered just basically lets it know, okay, I've locked the screen, I'm in control, you need to satisfy my criteria in order for me to unlock the screen. That locked variable is what it's going to tick off. So this only has a value of 1 in it. Only one thing needs to happen for the locking to get unlocked. So because we have 2 different ones throughout the layout or the level of the game, we have to do a check. So we know one of them has reached that viewport left coordinate. So if it's the first one, we're just going to randomly create, you'll see here, create object boulder shadow. So that's the shadow that starts to let the player know that something is falling toward the ground. And we just create that boulder shadow on the foreground layer. We just make it appear somewhere in the visible area of the screen. I'm being lazy, so it's just a viewport left, which is the very leftmost border of the screen, but then keep in mind for this game, so you can see that frame. So that's, I forget how wide that is, but I know it's at least 40-ish pixels.
It's 50-something pixels
Nice.
on
Okay.
each side or something like that.
Yeah, and that shadow is pretty wide, so I knew I didn't want the shadow to be half off the screen or anything, so I just picked a safe number off the top of my head, and luckily it worked out for me. That's what the plus 66 is. So if I put it totally viewport left, it would be completely obscured by that frame. And then I did also plus a random number between 1 and 240. So that's going to basically make it appear somewhere in the actual visible area of the screen. And then the Y coordinate is not random. It's exactly at the bounding box top of the floor collide. And if we look here, this big red thing that is actually the collidable floor in the level, the bounding box top means the absolute top of the collision rectangle. So that's basically the physical floor. And then we need to do a Z order thing because we want this shadow to go under everything, like an enemy or especially the player. You don't want the shadow going over the feet of the player. So that's why we do this. Move in front of tile map 3. Tile map 3 is the actual foreground environment art, and that's pretty much under everything else in Z order. So it's really safe to say just put the shadows Z order right on top of that. And then if the value called which of scroll stopper equals 1, that means it's the second one. Oh yeah, and this is a little bit interesting. When you hit the second scroll stopper, what happens is I wanted 2 ice boulders to come crashing down onto the ground, but I wanted them to never hit each other. So they're going to come in sequence a couple of seconds apart. First one slams down in a random coordinate, and then the other one does. But if they were both truly random, covering the entire area of the screen, there's always that chance that one will land right on top of the other, and I didn't want to do special case code where, oh, if that happens, then one will shatter the other, or whatever.
Right, yeah.
So I figured out a good solution to that. Basically now each of them is definitely going to only appear on some portion of the left or the right of the visible screen. So they can each only appear on one half of the screen. So what I did was I just made something that checks from a random number. We have a 50-50 chance. And then so if that is the case, what it's going to do is going to create this first boulder. You can see viewport left plus 66 plus random 100. So that is the left-hand side of the screen, and it's only going to cover roughly the first half. And then the same thing for the Z order. And then there's this really cool system command you can do, which is to just tell it to wait any amount of time and then do the rest of the events in that line. And the cool thing is, don't worry, it doesn't literally freeze the whole game for that amount of time. It still keeps going with the rest of the game. So it's a really powerful thing that's really handy for sort of choreographing certain events. So I made the first boulder appear, and then I just make it wait 3 seconds and then create the second boulder, and you'll see now that this one is viewport right minus 66 minus random 100. So it's using the exact same formula but from the other side of the visible screen, and we're subtracting since we're coming from the right instead of the left. So that's going to make sure it appears on the right hand side of the screen. You could see here this has this if this is true, if this is 0. What else does, if you create an else line, is that means if this is not true, then do this, and this is the exact same thing, only we have it in reverse. It creates the one on the right-hand side first, and then 3 seconds later creates the boulder shadow on the left-hand side.
I like that it has a little randomness. So
Yeah.
That, adds replay value.
Yeah, we actually do have a lot of checks against a random number that's generated in the moment for decisions for even some of the basic enemy AI. Mm-hmm. So that does help make things a little less predictable, and you can't rely on pure memory. You actually have to just develop good timing and reflexes based on what's actually going on.
Right.
So as you can see, so far we're just creating the boulder shadows. So I'm skipping down here a little bit. So boulder shadow, animation frame equals 4. So if we look at, let's find the boulder shadow, here it is. And then, so here it is. You could see that it has up to a 4th frame, which is, of course, programmer numbering. It's 5 frames. And it loops. If I click here on the animation, you could see it loops back around to frame 4. So that's the biggest the shadow gets. And it just, so it'll play getting bigger and bigger, and then it'll stay on that biggest size. So basically we have an event when it equals 4 only happen once. So that's another really useful thing in construct. You have trigger once. So that means only do this the first time this happens for this particular boulder shadow sprite. And it's going to create the actual ice boulder. And if you look at the coordinates, create it on layer foreground, which is the same as the player. at boulder shadow X, which makes perfect sense, the same exact horizontal position as the shadow, but then negative 30, and remember negative 30 is relative to the whole screen. So 0 is the absolute top of the layout, so negative 30 would be even 30 more pixels up in the sky, basically, where you can't see it yet. And then the ice boulder, it has a bullet behavior, and we're just making sure that its angle of movement is 90, which is straight down. And then we create an ice boulder screen shadow, and the whole screen tints dark a little bit, like something big above you is blocking out a little bit of the sun. It's basically just a big tiled background object that's got a dark semi-transparent color on it, and it's got its own fade behavior. So all you need to do is create it, and it's going to fade in, so it's going to like quickly get dark, and then it's automatically going to fade out, and then it will automatically destroy itself, all within like a fraction of a second. So now that it's created and it is falling with the bullet movement, it's moving straight down. This is the event that checks if the boulder is actually at the exact Y coordinate or lower of the top of the floor. If the Y has passed or is equal to the top of the floor, and then is its animation falling playing, which is its default animation, then we're going to turn off its bullet speed, we're going to disable its bullet movement, we're going to play a loud boom sound. Now we're setting the animation of the ice boulder to embedded. There's its normal falling animation with a fairly jagged bottom, and there it is embedded, which not only is a cool frame of it partially embedded in the ground, the snow is bunched up around it, and then this actually shows a little bit of damaged ground, and then it's actually going to play an animation once it hits. And you can see we're carefully using the duration of each frame, so it stays stuck in the ground for a while without shining, and then it moves on to a very quick shine animation, and then once again it lingers for a little bit. So this allows us to really create some nice cinematic timing, so everything just doesn't happen at the same exact so many frames per second. It goes boom, and then, you know, it gives you a chance to adjust to it being there, to focus on it. There's other effects we do. We do some particle effects, and we actually fade the screen white, which you'll see in a minute, to kind of simulate microscopic dust powder getting kicked up into the air and then settling back down. So we kind of let all that happen mostly before the shine animates. And that'll just also draw the player's attention back to it in hopes that they notice, oh wow, there's like a person embedded in this ice.
Right, yeah.
And then static is just the same thing without the shine. And then because it's moving so fast, depending on how fast the person's computer or Android device or whatever they end up playing this game on, this thing is moving so fast, there's always that chance that it managed, in between loops of code, that it managed to move down kind of too far to look nice. So we teleport it back up to the exact Y coordinate to be level with the floor. And then we set, if you remember from a video a million years ago, I have a sprite called the camera that basically the actual scrolling of the game follows this camera sprite. And the camera sprite follows the player under most circumstances. But then on the Y coordinate, it doesn't follow the player as much. It can also follow this variable called quake. And I use that variable, and I use a little loop of code that when that quake is not set to 0, it changes the Y of the camera position to a different Y coordinate, getting smaller and smaller over a short amount of time, which creates a nice screen shake animation. So basically we set this value very high to make a pretty big violent screen shake when the ice boulder hits the ground. And then again, the ice boulder itself, we want to make sure that its Z order is not over the player, and especially once it lands, it becomes a solid object that the player can actually jump on top of, and we want to make sure the player's feet go on top. And then we create some shrapnel. That's what all these are. We just have separate sprites with their own platform behavior so that they can move in graceful arcs pretty easily without me having to actually program graceful arc movements. So all I do is generate them in the areas that make sense around where the boulder hit, and spawn them out and send them moving off in these different directions by controlling their vector X, which is their horizontal movement, and their vector Y. And as you can see, I added some randomization there as well. And then there's the same thing for something I call Snow Cloud, which is just another particle effect sprite that is just a quickly animated thing to make it look like some more heavy tufts of snow have also got kicked up. And then this just does more of the same, The other thing I do is I create that thing called snow fade, which is the fade to white. And it's never completely solid white. It's always semi-transparent. So it's just another atmospheric effect. And again, even though we're making this game for modern platforms on Construct 3, there will eventually be a port to classic Amiga and maybe even other retro consoles in the future. So we want to make sure we're doing things that look like they're being done or that could be very well replicated on classic 16-bit systems. And then we do a check here. So instead of doing more complicated programming, I just did a very sloppy thing and said, this ice boulder definitely just fell. It was definitely in the exact horizontal position of this particular ice boulder shadow. So there's no way it's not overlapping that shadow that had spawned it. So I'll just check, are you overlapping the shadow? And if you are, then destroy the shadow because you don't need the shadow anymore because it's now embedded in the ground. All right, before we cover this event actually, because what this does is it destroys the scroll stopper and initiates that quick camera movement to bring the camera back into alignment with the player to unlock the scrolling. That doesn't happen until that variable called locked needs to be brought back down to 0. So let me quickly find the event that subtracts from locked. There we go. Okay, so you'll see here, ice boulder on animation embedded finished for each scroll stopper. So we're going to do a loop for all of the scroll stoppers. If the triggered variable of that particular one that it's looping through is greater than 0, which means we know it's that one in particular that's activated, then what we do is we subtract 1 from that locked value. So in the case of the first one, when that boulder is done playing its embedded animation, then we subtract 1 from locked, and then we set the animation to static. So that meets all the criteria necessary for unlocking the first scroll stopper. So once locked equals 0, which it now does, once the player is not stuck in a move, but he's on the ground, we destroy the scroll stopper, we set timescale to 0, which means we're literally freezing time, and then we set locked to 0 of the camera. That frees up scrolling again, and then we set camera timescale to 1. So if you set the overall time scale to 0, everything gets frozen. But the cool thing is you can actually set the time scale after that fact of particular things to kind of release them from that frozen time. And then we use its move to behavior to move the camera to the same exact X position of the player. So that's basically giving the camera a second to get back in proper sync so that there should be no jarring movement, because the player can end up like all the way on the far right or far left of the screen. And then if we just immediately pop it back to normal scrolling, the whole screen would just immediately teleport to center with the player. So this basically
disorienting.
Yeah, exactly. And then you could see, so it sets the player stuck in move to 1, which means he can't do anything, and we ignore his platform inputs as well. And then this is the same exact situation, but this is for the second scroll stopper, and its locked variable starts at 2 because there's 2 boulders, but then each time a boulder hits, it subtracts 1 from locked. So, and then this just, we've told the camera to move, so when it's reached its target, you set time scale of the game back to 1, and you set stuck and move back to 0, so now the player is not stuck in his move, and you stop ignoring the user input. Ice Boulder is overlapping hero, so this literally just makes it hurt the player while it's falling. So we make sure the player is not already flashing. If he's flashing, that means he's invulnerable because he was just hurt by something else. Oh, and then these are leftover things from, I stole this action from when he was getting hit by an enemy. So those things should not be there, so that's a little bug fixing there. So basically, if the player is not invulnerable at the moment and it hits him while it's falling, it's going to set his animation to hit, it's going to set him to be stuck and move, it's going to make him bounce up a little bit, it's going to make it ignore player input until he's done playing his hit animation. In this case, because it's a giant ice boulder that slammed down on your head, it takes 2 points of damage instead of the usual 1. And then we make the player flash, which makes him invulnerable to further damage for 2 seconds. And then we call a function we had made a long time ago called update health, which simply updates his health bar to reflect the fact that he took damage. And we play his oof, I've been hit sound effect. And then if the ice boulder is on the left or the right of the player, we set an X hit speed value of the player to either a negative or positive number, and there's code elsewhere in the game logic that while he's playing the hit animation, he'll move in that direction. So, like, he'll automatically bounce away from the direction of the thing that hit him. This is just some tidying up of things. It's not necessary for this modern platform. There's only ever 3 boulders, and once they're off screen, Construct already does a good job optimizing and not really worrying too much about things that are off screen. So it's not a huge deal, but I just make it so that once the player really walks long past the boulders, it'll destroy them. That is mostly it. The snow cloud, the like poofs of snow that get created as particle effects, they simply destroy if they hit the ground. They do also have a fade behavior. So because of the randomness in the Y velocity, sometimes they'll finish their animation and fade and destroy themselves before they hit the ground. But if the random number aspect makes them only go up not very high, then they could land before they're done with the animation, which just looked really silly. So basically I made it so, okay, if you hit the ground, immediately destroy yourself. So that's just a little tidying up for the visual quality of the effect. Whereas the snow shrapnel, which is like a piece of stone with snow on it, we don't want that to just fade away and disappear. There's no need for that. So we actually make it so that when it lands, we change its animation, just like the big ice boulder has that special animation when it's embedded in the ground. So we set its vector X. We make sure it's not moving horizontally at all as soon as it hits the ground. And then we change its animation to rested, which just makes it look like it's lying nicely in a nice little cozy bed of snow. And then we disable its platform movement. Oh yeah, so here's another interesting one. So if the boulder is not overlapping the player, and if it is playing its embedded animation, so now we know it's on the ground, it should be a platform now that the player can jump on. So it has a solid behavior, but that solid behavior starts disabled. So what was happening at first, I just gave it a solid behavior, and I had the code that it hurts the player when it lands on him, but what happened was, as soon as it landed on the player and hurt the player was still had the platform behavior, and suddenly he was encased in this giant solid. And the game, like most game engines, it'll just do this thing to push any platformer object out of the solid thing.
Right.
But Construct didn't do that. It just like, you were just stuck. You became embedded in ice just like your friend was embedded in the ice. So what I needed to do was make it so that the solid behavior does not exist when it's falling and won't turn on until the player moves away from it. So when it lands, it already hit the player if the player was there, so it already behaved as though it was solid. It did the damage. But from that point on, if the player jumps up and lands on it, we want it to be solid. So what I did, that's why I did that code, basically it waits for the first moment that the player is not overlapping, and then it'll become solid. That way, if you walk away and come back, it's suddenly solid, or if you jump up in the air, you're going to completely clear it because of the jump height in the game, and then you'll be able to land right on it seamlessly. So that worked great. But there's one other really cool thing, and that is these snow shrapnel sprites. Remember, they have their own platform behavior. And in this situation where there's the 2 boulders that appear 3 seconds apart, the second boulder that appears, when it creates that shrapnel, every once in a while the 2 boulders would be close enough that the shrapnel from one of the boulders would land on top of the previous ice boulder, which that sounds pretty cool, but that shrapnel sprite is wide enough, and it's got like the built-in snow mound stuff, that it could be hanging half off of the top of the boulder with this flat snow just hanging in the air. It just looked bad. So there's this really cool thing that I just discovered. It was one of those great moments, and this happens a lot with Construct. It takes so many things into consideration. There's actually collision in solid filtering. So you can see every time we create one of these shrapnel things, we set solid collision filter to boulder and exclusive. So let me go back into the spriter layout, and you'll see on this boulder, in the solid behavior, there's now tags that you could separate with a space. So you could give it multiple tags, and I gave it the tag boulder. So if you're not filtering, it doesn't matter. So I don't have to say, okay, if the player lands on something that has a solid filter called boulder, I want you to land on that too, right? Because that's not exclusive or exclusive. It's a solid thing, but it has a tag. But then you could give a specific sprite, which we did in the case of the shrapnel, because we're very specifically giving this that filter to boulder. So I'm excluding anything with the solid tag boulder. So it's going to go right through the boulder. So that's what that does. And that was just an incredibly fast, easy. It was one of those moments where like, it would be so cool if it could do this. And then I did a search and bam, it just had the feature built in and it was super easy to use. So kudos, Scara Construct is an awesome authoring system that makes so many things like that that could have been really complicated, incredibly simple. But that's actually all of the events that make this work, and we hope this was useful for you, and tune in next time.
If you enjoy our content and want to keep up to date on our games, please leave a like and subscribe. Also, if you want to support our projects, consider becoming a patron. The link's in the description, and we'll see you soon.